Assalamu alaikum all viewers and dear students. Today we will discuss or try to solve the exercise 2.3 question number first. Limit x tends to 1 x under root minus 1 divided by x minus 1. We have already discussed some rules of the limits in the previous video. Let's come we start to try to solve the question number 1 part C. Solution. Now this limit is applied to numerator and denominator term by each value. So we are applying this limit. Limit x tends to 1 x under root minus limit x tends to 1 divided by limit x tends to 1 x minus limit x tends to 1. According to the limits constant rules, here is constant rule is applied, but here we directly put x is equal to 1 under root minus, and here is constant rule, we get 1. Similarly here we put 1 minus 1. So the result is 1 minus 1 and 0 divided by 0 form. So this is undefined case. In case of undefined, we are proceeding factorization method or rationalization method or L-Hospital rule. So these are the methods we are applying in the limit to solve the question. Now we are here using rationalization method. Limit x tends to 1 x under root minus 1 divided by x minus 1. That means that if we take the conjugate of the numerator term, so we are taking the conjugate of the numerator terms. So here is we take the conjugate of this one. It means that we are multiply and also divide by the conjugate of x under root plus 1. For both are cancelled to each other, there is no effect on the question. Now here we can use the formula a minus b into a plus b. The result is equal to a square minus b square. So here expanding by the formula x under root whole square minus 1 whole square divided by x minus 1 into x under root plus 1. So square and square root are cancelled. We get the answer limit x tends to 1 x minus 1 divided by x minus 1 into x under root plus 1. So this term and this term are cancelled. Here limit x tends to 1, we get 1 divided by x under root plus 1. Now limits are applied to the numerator and also denominators by each term. So we can write limit x tends to 1 divided by limit x tends to 1 x under root plus limit x tends to 1. So this is the constant rule. We have the constant rule limit x tends to a, c is equal to c, because here in this value in the function replace a function x is not available, so we write c. Similarly here we write x is not available, so we write 1 divided by, here x is present, it means that we put the value of x is equal to 1 by under root plus, here is also constant root 1. So 1 divided by 1 plus 1, so we get the answer 1 by 2. D, limit x tends to 1 by x minus 1. If we directly apply it here, we get undefined case. Now look here, limit x tends to 1 by x minus limit x tends to 1 divided by limit x tends to 1 x minus limit x tends to 1. So if we are applying 1 divided by 1 and here is 1 is minus 1. So 1 minus 1, 1 minus 1. So the result is 0 by 0 form, which is undefined case. Now we are taking here LCM, limit x tends to 1. Here we take LCM. It means that x is LCM. So we get here 1. 1 is multiplied by x. So we get x divided by x minus 1. Now we can write this term, limit x tends to 1, 1 by 1 minus x divided by x, and this is we can write 1 divided by multiply by into 1 over x plus x minus 1. Now we are trying to finish this value. If we change common here, so the result will be same, limit x tends to 1, we taking common, minus common, and here we get x minus 1 divided by x into x minus 1. So both are cancelled. We get limit x tends to 1 minus 1 divided by x. Now we are applying limit x tends to 1 minus 1 divided by limit x tends to 1 and x. So here is constant rule is applied, minus 1 we get, and here we put in the place of x is equal to 1. So the result is minus 1 to 0, limit x approaches to 0, 1 minus sin x divided by cos square x. If we directly apply limit x tends to 0 according to the limits rules, minus limit x tends to 0 sin x divided by limit x tends to 0 cos square x. So we get here 1 and here we get sin 0. So cos 0 cos square 0. Here is we get 1 minus sin 0 0, sin 0 0, sin 0 0, and divided by cos 0 is equal to 1. So we can write 1 divided by 1, so result is 1. Tangent x divided by x. Now we are right tangent x, we know that if we directly put here limit x tends to 0, tangent x divided by limit x tends to 0 x. So it means that tangent 0 divided by 0 is equal to tangent 0 sin 0, 0, so 0 divided by 0 form. So this is undefined case, so we are using some formula factorization method or formula method. Tangent x, we know that tangent x is sin x divided by cos x. According to this formula, if we open this one, so limit x tends to 0, tangent x we can write sin x divided by cos x divided by x. So we can write this terms, limit x tends to 0 sin x divided by cos x, and we divide this division, we change into multiplication, we can write 1 by x, and here is x divided by 1 we change into multiplication, 1 divided by x. Now we have one of the rule, limit x tends to 0 sin x divided by x is equal to 1. This is very important rule. According to this rule, we are separate this limit x tends to 0 sin x divided by x into 1 over cos x. Now we are separately applied limit x tends to 0 sin x divided by x into limit x tends to 0 1 divided by cos x. So this is equal to one of the formula, limit x tends to 0 sin x by x is equal to 1. In the place of this result we put 1, and here we are applying limit x tends to 0 by 1 and limit extends to 0 cos x. Now 1 dot and here is constant rule, we put 1 and here cos 0 is equal to 1. So 1 divided by 1 is equal to 1. Tends to 0 secant x minus 1 divided by x into secant x minus 1. Now we are applying limits on numerators and denominator terms. To apply on each term, limit x approaches to 0 secant x minus limit x approaches to 0 1 divided by limit x approaches to 0 x secant x. Now if we are x put directly here, secant in the place of x we put 0 and here constant rule is applied. Similarly, here 1 0 multiplied by secant 0. So according to the formula, secant theta is equal to 1 over cos theta. So it means that, and here if we put secant 0, so this will be 1 over cos 0. Now cos 0 is equal to 1. So 1 is, we get 1. And here secant 0 we get 1 minus 1 and something is multiplied by 0 we get 0. 0 divided by 0 form. So this is undefined case. Now we are expanding by some formula here. Secant theta is equal to, we know that secant theta is equal to 1 over cos theta. Limit extends to 0. Secant theta we can write cos x minus 1. Similarly here secant x 1 by cos x. Now we take here LCM. Limit extends to 0. Cos x is the LCM. Here we get 1 and cos x is multiplied. सब करता बिजली मोहन बिजली रोला बिजली मोहन आन कड़ाला तब देने पे स्विच में चौला दे बड़ा यूपीएस वाला तब देता हूँ यार now 1 by x we are taking, so cos is the LCM, so this cos is multiplied by 1, so we get cos x divided by x divided by cos x. So we can write this one cos x are cancelled to each other, so we can write limit x tends to 0 1 minus cos x divided by x. Now if we directly put here, so we can once again undefined case, it means that we are taking rationalization method here. Limit x tends to 0 1 minus cos x divided by x and 2 1 plus cos x divided by 1 plus cos x. Now here we are using a minus b, a plus b, so a square minus b square. Limit x tends to 0. We can use here 1 square minus cos x whole square divided by x into 1 plus cos x. So now if we are apply here limit x tends to 0, 1 square we get 1, and here cos square x, we get x into 1 plus cos x, and limit x tends to 0, we can write here sin square x. This is the formula, divided by x into 1 plus cos x. Similarly here we can write this term, limit x tends to 0, sin x into sin x divided by x 1 plus cos x. Now we can write, this is the formula we are making, limit x tends to 0, sin x divided by x dot limit x tends to 0, sin x, 1 sin x is remaining, and divided by 1 plus cos x. Here this result is equal to 1, and here we put sin 0 and 1 plus cos 0. So sin 0 is equal to 0, and 1 plus cos 0 is equal to 1. So 0 divided by 2 is equal to 0. Square 7x divided by 7x. We can write this terms, limit x tends to 0, sin 7x we can write whole square, we can write according to the rule 7x. It means that if we directly apply limit, so we case undefined. So if we are applying limit x tends to 0, sin 7x whole square, we can write this one, limit x tends to 0, 7x. So here if we put limit x is equal to 0 in the place of x, sin 7 into 0 whole square, so divided by 7 into 0, so result is 0 divided by 0 form, which is undefined case. It means that now we are taking some rules, and here limit x tends to 0, sin square x, sin 7x whole square, we can write sin 7x into sin 7x according to the exponent rule, we can write 7x. Now we are making limits a parted formula, limit x tends to 0, sin 7x divided by 7x into limit x tends to 0, sin 7x. In the place of this is the rule, so result is 1, and here we put sin 7 into 0. So result is 1, sin, this is sin 0. So sin 0 is equal to 0, so result is 0. Thank you very much for watching. Once again, appreciate in advance. Please subscribe my channels. Once again, thank you.